Hello, I am Professor Dr. Satishkumar Kashid, Professor in Civil Engineering, presenting a topic Watershed Development for Water and Soil Conservation in Semi-Arid Regions. Learning outcomes. At the end of this session, the students will be able to describe the need of watershed development in semi-arid regions. The students will appreciate the work done on watershed development front implemented by Maharashtra state government under Jalayukti Shivar scheme in Solapur district of Maharashtra state under leadership of Honorable Collector Mr. Tukaram Munde. Overview of this presentation. Firstly, we will discuss about the major schemes of watershed development implemented by Maharashtra over a period of time. Then we will see the classification of watersheds. Then we will discuss the watershed approach for water and soil conservation. Then we will see in situ soil moisture conservation treatment, and thereafter we will go and discuss area treatment. Now, what activities can be taken up in watershed? So, different sectorial activities can be taken up in the watershed. The works can be soil conservation, water harvesting, rehabilitation of degraded areas, social forestry, agroforestry, horticulture, silvipasture, etc. These are distributed in different watersheds in different parts of a district. Now, let us see what is a watershed. So, watershed is a geohydrological unit draining to a common point by system of drains. So, we can observe that here this is a ridge line, this is a water divide, and a river originates from here, proceeds further, and again these are the tributaries coming and joining this particular river. As river approaches towards sea, it collects more and more discharge, and we find that it collects water as well as sediments from a watershed. So, both water management as well as sediment management is important. Now, let us discuss what is definition of watershed development. Watershed is a geohydrological unit draining to a common point by a system of drains, as we have seen just now. Watershed development refers to the conservation, regeneration and the judicious use of all the natural resources, particularly land, water, vegetation and animals, and human development within the watershed. What is watershed management? Watershed management is a term used to describe the process of implementing land use practices and water management practices to protect and improve the quality of water and other natural resources within a watershed by managing the use of those land and water resources in a comprehensive manner. Now, here are the major schemes which were implemented by Maharashtra state government for watershed development over a period of time. So, first was the Bombay Land Development Act 1942. Thereafter, Western Ghat Development Program was taken up in 1974-75. Thereafter, Drought Prone Area Program was launched in 1974-75. Then, Integrated Watershed Development Program started in 1982-83. Thereafter, National Watershed Development Program was taken up in 1987-88. Then, River Valley Project in 1987-88. The Department of Water Conservation for Maharashtra State was established in 1992. The scheme Manarega was started in 2005, and then Integrated Watershed Management Program was started from 2008. So, all these schemes basically focus on watershed development and watershed management in a broad sense. Now, watershed treatment in different ways. It has also a history. The idea of compartment bunding below 750 mm annual rainfall was implemented right from 1943. After graded bunding in assured rainfall zone was practiced from 1958. The terracing for high rainfall zone was started from 1959. Earthen Nala Bandharas were started from 1969, land leveling from 1985, diversion and cement nala bands in 1989, aegis linked horticulture from 1990, gabion structures from 1994, CCT and farm ponds from 1995, deep CCT from 2012. Now, let us see how watersheds are classified on the basis of the extent of area. When area is in between 500 to 600 hectares, we call it as a micro watershed. A watershed of area 3000 to 5000 hectares is called as mini watershed. Area 15,000 to 20,000 hectare we call it as sub watershed, whereas 30,000 to 40,000 hectare area it is called as GSDA watershed, and for a river valley there is no limit of area. Now, this particular map shows us the water conservation structures which are prevailing in the Solapur district of Maharashtra state. It gives idea about the CNBs, KTVs, masonry structures, earthen bunds, etc. Now, let us discuss what is meant by a watershed approach. Just see, so this is a watershed and this is a ridge line of watershed. It means it is a water divide. A drop of water falling on this side of the ridge line will come into this river system. A drop of water falling on this side will move on the other side. It will not come to this watershed. So, the first zone which is near to the ridge line is called as a runoff zone. So, in this particular green shaded zone, it is called as a runoff zone. So, here we provide the upper reaches treatment. Nextly, the zone in yellow is called as recharge zone. Next zone is storage zone. It means three types of watershed development structures will be constructed, and they are different for runoff zone, recharge zone and storage zone, that one should understand. As you know, the runoff zone will have a steeper slopes, recharge zone will have the mild slopes, whereas storage zone comes along the length of a river where we are going to construct the water and soil conservation structures. This is the outfall of this catchment. So, this particular figure gives us the idea about the different structures which are constructed in the watershed. Say, for this hillock we see the vegetative bunds. On this hillock you can see typical continuous contour trenches. Here we can see in low reaches the Vanarai bandharas which are constructed, whereas here we see the earthen structures like what we call it as percolation tanks. Again, terracing is done at higher elevations and so on. Wells are recharged in the recharge zone. In the agricultural fields, we can have the farm ponds, whereas cement nala bunds are constructed across a nala. This is a percolation tank. We call it as a Pazar Talav in Marathi. So, these are different structures which are constructed in a watershed for water conservation as well as soil conservation. Now, let us discuss what type of treatment is given in upper reaches, what type of treatment is given in middle reaches. So, in upper reaches, we can go for continuous contour trenches, deep continuous contour trenches, loose boulder structures, vegetative bunds. Whereas in middle reaches, we can have small earthen bunds, farm ponds, gabion structures, compartment bunding and well recharge. In low reaches, we have gabion structures, earthen nala bunds, cement nala bunds, Vanarai bandhara, well recharge and diversion bunds. Let us see those one by one. The approach can be discussed in this way also, that area treatment, drainage line treatment, water management and crop diversification. So in area treatment, we go for continuous contour trenches, deep continuous contour trenches, vegetative bunds, compartment bundings, well recharge, graded bunding, farm pond, terracing. Whereas for drainage line treatment, one has to adopt loose boulder structures or gabion structures, earthen nala bunds, cement nala bunds, vanarai bandhara, diversion bunds, percolation tanks. And also one should think about the water management and crop diversification for effective management of available water. Now, here in situ soil moisture conservation treatment, which can be also called as a low cost treatment. So, first technique is sowing and intercropping on contour. So, this is example. So, the sowing and intercropping is done along a contour. We know that the water flows perpendicular to the contour, and we will find that the water will find a time to penetrate into soil when we are providing the cropping along a contour. One can also go for a mixed cropping as shown in this way. That is also one of the best ways for soil and moisture conservation. Also one can have the dead furrows, and also one can go for mulching. Mulching, you know that the dry leaves of the vegetation are spread over the soil, so which avoids direct penetration of sunlight into soil and thus conserves the moisture available with the soil to a great extent. Now let us discuss the area treatment. The first technique of area treatment is the continuous contour trench. So this is upper reach treatment where slopes are reasonably steeper. It reduces the speed of water flow, it conserves the soil, it increases the infiltration of water into soil. It also increases area under cultivation, and it is recommended for these slopes from 0% to 33%. So these are the pictures of the continuous contour trenches. See, these trenches are dug along the contours. You can see a person standing in the CCT, the depth of water and the volume of water that is collected. One can have number of models of continuous contour trenches depending upon the land slope. So land slope 0 to 4%, 4 to 8%, 8 to 15%, 15 to 33%. In this model, for 4 to 8% slope, the permissible trench length per hectare can be 927 meters. Means in 1 hectare you can have trenches of length 927 meter. For a particular trench, the length of one trench should be 15 meter, whereas width of the trench should be 0.6 meter. Trench depth will depend upon the soil type. It can be 0.3 meter or 0.45 meter and so on. Now let us discuss about the deep continuous contour trenches. Deep continuous contour trenches come under upper reaches treatment. They are effective in the DPAP area. It improves the groundwater level by percolation. It conserves the soil, and water storage up to 2.4 lakh liters per hectare can be achieved. Deep continuous contour trenches are recommended on a land of a slope less than 8%. A trench of section 1 meter by 1 meter and length per hectare can be up to 240 meter. Each trench may have a length of 20 meter, and there should be 33 meter distance between two trench lines, and the structures are to be staggered. So if you see carefully, the section is 1 meter by 1 meter. This is the earthen bund, and the trench length per hectare is limited up to 240 meters. So just these are the deep CCTs, the width of a trench, the depth of a trench, length of an individual trench can be understood. Now let us discuss about the compartment bunding. Let me show these compartment bundings. So this is a compartment bunding. So this is a compartment bunding. This is a compartment bunding along a bund of the agricultural field. So let us discuss once again. So compartment bunding is a middle reaches treatment. It is used to improve the water holding capacity of soil. It improves the soil fertility. It conserves the soil. It is recommended in the area in which rainfall is up to 750 millimeter. Recommended for the land having slope up to 4%. Work should be done with ridge to valley concepts. It must be on continuous area and total area, not on scattered area. Prepared bunds should be protected by farmers with vegetation. Water waste wear is must to remove excess water. So for land slope 0 to 4% in light soil, in medium soil, in heavy soils. The base widths differ. For example, for medium soil, base width will be 2 meter, height will be 0.85 meter, top width will be 0.3 meter, side slope will be 1:1, section of bunds in meter square will be 0.8. So this is type design. Length of bunds in meter per hectare can be up to 200 meter. So section of bund will be top width plus base width divided by 2 into height, whatever it is shown here. So this is top width of bund, this is the bottom width of bund, this is height of bund, and this is a side slope. So these are the compartment bunds. These are constructed by excavating a soil here and dumping the soil here. This is a picture from village Pare, Taluka Sangola, district Solapur. See the compartment bundings conserving the water as well as soil along a mild slope. So we can see the change which has happened due to the water conservation works. One more way of water conservation is well recharge. Firstly, I will show you the picture. This is a well. Here there is a filter tank not to allow the sediments to enter into the well. Here this is a storage tank of the raw water. So raw water passing through filtration tank and then going to well. So the same schematic is here. This is a storage tank. It receives the water from inlet. Thereafter it is passed to a filter which consists of sand, gravel and stones, and then water is allowed to go into well for recharge. So this is a middle and low reach treatment. It should be undertaken for wells in water scarcity areas. Extreme care has to be taken for only filtered water should enter into the well. So before adopting the well recharge techniques, see at what depth water is, and after the same well one can see the rise in water level considerably. We can see the well recharge work which is ongoing here. So this is a filter under construction. So this is a filtered water which is coming inside the well for recharge. So this is the recharged well. Just see the arrangements of recharging, the filtered water coming into the well which is constructed with a concrete wall. We can recharge the tube well also. So here we see how tube well recharge can be done. Now farm ponds. Farm pond is a middle reach treatment. It is constructed on private land and water is used for protective irrigation. It improves groundwater level and it is recommended on the land up to 3% slope. A farm pond should have a catchment area of 5 to 10 hectares so that sufficient water can be stored in the farm pond. The water from the farm pond can be used for supportive irrigation for the horticulture as well as other crops. So total runoff is given by equation K into P into A divided by 10, where R is runoff in millimeter, K is available runoff from average rainfall percentage. So the values are 8 to 10% for heavy soils, 10 to 15% for medium soils and 20% in light soils. for K, whereas P is average rainfall in millimeter and A is catchment area in hectares. The size of farm pond should be taken into consideration for storage of about 50% of total runoff available. This slide gives us the sizes of farm ponds and required soil excavation in meter cube. So for a farm pond of size 25 meter by 25 meter and 3 meter deep, we may need to do excavation of 1461 meter cube. Here we can see the farm pond, see the slope which is given to the sides of a farm pond, and when water is stored in the farm pond, how it looks. One can also use the plastic paper to reduce the seepage of water through the farm pond. Next technique is graded bunding. Objectives are such that it is a middle reach treatment. It is used for soil conservation as well as water conservation. It reduces the speed of water flow. It improves the rate of water infiltration, and it is recommended for a slope up to 4%. Sufficient soil depth should be there when we want to adopt the graded bunding, and it is specially recommended for assured rainfall zone area like Vidarbha and Marathwada. So just see, this is a graded bunding. Technical specifications again depending upon slope. For example, for a slope of say 2.4%, the base width can be 2 meter, the height of bund can be 0.75 meter. It means the height of this bund 0.75 meter. The top width should be 0.5 meter. The side slope has to be 1.2:1. The side slope has to be 1.2:1. Section in meter square will be 1.05 meter square, and length per hectare can be 165 meter. So in 1 hectare area you can have about 165 meter length of the graded bunding. Now terracing. So just see, this is a terracing. In steeply sloping areas, when we want to go for agriculture, we need to construct such terraces. So terracing is upper reaches treatment. It is recommended in high rainfall zone, that is more than 1000 meter, and in paddy areas, it means in Konkan regions we adopt this. On every 10 to 20 meter distance, fields are prepared on slope. It's a costly treatment. Slopy land can be brought under cultivation by terracing. Slope should not be more than 8%. So just see here. So this dotted line shows the original land of slope 20 to 30%, whereas this is a modified profile of a land. We cut here and we fill here, and this is a shoulder bund. Benches are constructed here, and then we have these terraces here where one can go for a crop in this way. Now let us discuss how we go for drainage line treatment. The first treatment which we discussed here is loose boulder structures. This is upper reach treatment in hilly areas and light soils where continuous contour trenches work is not possible. We should have sufficient boulder stones available nearby, and then these loose boulder structures will make the running water to work, giving time for percolation. It will also conserve the soil and water reasonably. The technical specifications for loose boulders, for example, for a slope of 0 to 5% in middle reaches, the base width can be 2.5 meter, height can be 1 meter, top width can be 0.5 meter, side slope can be 1 to 1, section 1.5 meter square. So one can see the loose boulder structures which are constructed at Boroti in Akkalkot Taluka of Solapur district. Here this is a loose boulder structure constructed at Tarangfal Taluka, Malsheres district, Solapur. Now let us discuss the earthen structures. Earthen structures are upper and middle reach treatments. Earthen bunds are prepared in upper reaches where loose boulders are not available. It reduces the speed of water flow. It improves the rate of water infiltration. It conserves the soil. The catchment of such earthen structure should not be less than 10 hectares. Recommended side slopes of this structure are 1 is to 1.5, top width 0.6 meter, average height 0.72 meter, and cross section of the bund is about 1.2 square meter. So these are the type designs for the earthen structures. Now slightly bigger than that, there is a earthen nala bund. It is a lower reach treatment. It means where we store the water. It is recommended where slope of nala bed is less than 3%. It improves the groundwater level because the water which is stored against this earthen nala bund percolates and it works as the percolation tank. Water is used for protective irrigation and it increases the irrigated area. Width of nala bed should be between 5 to 10 meters. Now, there are special structures which are called as gabion structures. So, gabion structures come under low reaches treatment. So, what is gabion structure? Loose boulders are tightened together with a wire mesh. We can see the wire mesh which is tightly binding the loose boulders. It reduces the speed of water flow, thus reduces erosion. It is easy and low cost as compared to earthen nala bunds and cement nala bunds. It also improves the groundwater table. It is specially recommended for soil conservation. More than water conservation, it is better for soil conservation. Its height should not be less than 1 meter. We know that a 30 centimeter layer of topsoil ultimately supports the crops and vegetation from which we get the food grains. Now let us discuss the cement nala bunds. So this is a cement nala bund as you see, constructed in a masonry and plastered with a cement. So it is a lower reach treatment. It is recommended in low reaches of a watershed. It is just like a gravity dam, so it should have hard rock at the base. There should be cultivable land on both the sides of selected site so that we can pump the water which is stored in cement nala bund and use it for protective irrigation. Due to storage, it also increases the groundwater level. Water can be used for protective irrigation. Nala bed width should not be more than 30 meter and depth should not be more than 5 meter. Catchment area should be in between 40 hectare to 1000 hectares so that sufficient water can be accumulated in cement nala bund. So this is the cement nala bund. This is the where excess water will flow over this and what is stored on upstream side of this nala bund which can be used for protective irrigation. Now this is a diversion bund. It is again a low reach treatment. By constructing pakka bandara, water is diverted in the field after month of December. It can be used for paddy irrigation. It is low cost structure and demanded from the farmers. Water is made available to fields by gravity. So this is the advantage. It reduces speed of water flow. It improves the groundwater level and increases the irrigation. There is one special type of bandhara which is called as Vanarai bandhara. It is again low reach treatment. So here we use the empty cement or fertilizer bags which are available in ample with farmers. They are filled with soil and sand and then bandhara is constructed. Basically the activity is implemented through people participation. Partially it fulfills the water need of water scarce villages. Bandharas are constructed at the end of rainy season and height of bandhara is up to 1 meter. Every watershed treatment has its own life. Once constructed, we cannot expect them to exist and work for 50 years or 60 years. But rather, there is siltation in continuous contour trenches. At the same time, there is erosion of the bunds and so on. So it needs regular maintenance. So self life of the watershed treatments is for CCT it is 5 years. Loose boulder structures or earthen structures they have life of 6 years. Graded and compartment bundings have life of 8 years. Gabion structures have a life. Farm ponds have a life of 12 years. Earthen nala bandharas have life of 13 years. Cement nala bunds can have a life up to 23 years. So in conclusion, watershed management is a term used to describe the process of implementing land use practices and water management practices to protect and improve the quality of water and other natural resources within watershed by managing the use of those land and water resources in comprehensive manner. And the outcomes are prevention of soil erosion, regeneration of natural vegetation, rainwater harvesting and recharging of the groundwater table. Of course, the recharged groundwater comes to help through wells to the farmers. This enables multi-cropping and introduction of diverse agro-based activities, which helps to provide sustainable livelihoods to the people residing in the watershed area. So these are the references which are used for this presentation. Thank you.